This video is the answers to pages 438 and 439 homework questions, Unit 12, Lesson 7. Number 1A, the probability of A is 0.59, the probability of B is 0.83. B, the probability of A or B is 0.91. C, the probability of A or B is 0.9303. And in order to find that answer, you had to find the probability of A and B first. Number 2, the Venn diagram or the two-way table. B, the probability of M and T is 0.06. C, the two events are not independent, and you were to omit number 3. Number 4A, yes, they are. There are no red cards that are also a square. So are the events disjoint? Yes. A2, the probability of S or R is 3/4 or 30/40 or 0.75 or 75%. B1, are the events disjoint? No, they are not disjoint. There are 2 red 5s. B2, the probability of 5 or red is 22/40 or 11/20 or the decimal equivalent of 0.55. Number 5 is choice 2, and number 6 is 0.9. So if all of those are correct, you're all set. You can stop the video and go on to today's lesson. Okay. Explanations. Yeah, the probability of A is 0.59, that's 59% are paintings. And probability of B is 0.83, 83% are for sale. And suppose you're told that the probability of A and B is given to be 0.51. The probability of A or B, that's just plugging into the formula. Is equal to the probability of A plus the probability of B minus the probability of A and B. 0.59 plus 0.83 minus 0.51. Suppose now that you are not given the information in part B, but you are told the events A and B are independent. Find the probability of A or B. Well, if the events are independent, we would find the probability of A and B first, because we know we're going to use the formula to find the probability of A or B. That's going to be equal to the probability of A plus the probability of B minus the probability of A and B. So what is the probability of A and B? We're not using what was given in part B, right? We have to find it, given the fact that A and B are independent. So if A and B are independent, then the probability of A and B would equal probability of A times the probability of B. So 0.59 times 0.83 is 0.4897, and then put that in for the probability of A and B here. And then adding 0.59, 0.83, and then minus the 0.4897. Number 2, and I've really gotten to like the two-way table, so I'm going to show you that first. A traveler estimates that for an upcoming trip, the probability of catching malaria is 0.18. So I did malaria, not malaria, and then total. And the probability of catching typhoid is 0.13. So T for typhoid, and then not typhoid total. So probability of malaria goes here, total of 0.18. And probability of typhoid is here, 0.13. And the probability of catching neither of the two diseases, 0.75. So not malaria, not typhoid goes here, 0.75. And then our lower right-hand corner has to be 1.00. So the purple is everything that we know, and then you get the green, right? 0.13 plus 0.87 would bring us to 1.0. 0.18 plus 0.82 would bring us to 1. We've got the 0.87, so then 0.12 plus the 0.75 would get us 0.87. And we've got the 0.82 and the 0.75. So 0.75 plus the 0.07 would bring us to 0.82. And then 0.06 plus our 0.07 gets us to 0.13. Using the Venn diagram, I think it's a little more difficult actually. I didn't color code as I did with the table. So this is what we were given. Malaria, that was given, and typhoid was given, and neither, that would be outside. This was given, right? So right away, if this outside is 0.75, then that means this area is 0.25. So I would have gotten that by 1 minus 0.75. So I would get that. And then looks like I said, okay, well, what's this piece here? All right. Take 0.25, all of this, and subtract this portion of 0.13, right? Because this together is 0.25. And what is this piece? Take 0.25, subtract all of this, leaves us with this. So 0.25 subtract 0.13 leaves us with 0.12. So we would get 0.12. And then if this portion is 0.12, then, and this whole circle is 0.18. 0.18 subtract 0.12 is 0.06. So calculating the probability of catching both diseases, that was our malaria and typhoid, 0.06. C, are the events catches malaria and catches typhoid independent? Explain your answer. So independent if the probability of M and T equals the probability of M times the probability of T. So does 0.06 equal 0.18 times 0.13? No, it doesn't. 0.18 times 0.13 is this, 0.0234. Or independent if the probability of M given T equals probability of M. So the probability of M given T, so T is our denominator, 0.13 is our denominator, and of that, malaria is 0.06. So 0.06 divided by 0.13 is not 0.18. The two events are not independent. I'm not sure if 4A really requires explanation. Are the events the red card? The card shows a square and the card is red disjoint. Square, that's a black. There's 10 black cards showing squares, and there are no red cards showing squares. So yes, they are disjoint. The probability of square or red is going to equal the probability of square plus the probability of red minus the probability of square and red. So square was 10 out of 40, and red was 20 out of 40. And they were disjoint, so the probability of square and red was 0. Are the events the card shows a 5 and the card is red disjoint? No, because we have 10 red cards showing X's 1 through 10. So there's a 5 red card showing an X, and there's a 5 red card showing a diamond. So no, they are not disjoint. There are 2 red 5s. Calculate the probability that the card will show a 5 or will be red. So probability of 5 or red equals probability of 5 plus the probability of red minus the probability of red and 5. Probability of 5 is there's 4 5s, 4 out of 40. Probability of red, there's 20 cards that are red, 20 out of 40, minus the 2 red 5s, minus 2 out of 40. Number 5, choice 2 is the answer. So given this information, the events blue eyes and blonde hair are, well, are they dependent, independent, mutually exclusive? So I said independent if the probability of A and B equals the probability of A times the probability of B. So the probability of blue eyes and blonde hair equals the probability of blue eyes times the probability of blonde hair. So blue eyes and blonde hair was given to us to be 0.125. Does that equal probability of blue eyes 0.25 times probability of blonde hair 0.5? And yes, it does. 0.125 equals 0.125. So yes, they are independent. And since we do have a probability for blonde hair and blue eyes, they cannot be mutually exclusive. If they were, then the probability of blonde hair and blue eyes would be 0. So choice 2 only. They are independent. And number 6, what is the probability of a volunteer getting well given that the volunteer received the medication? So I said I let W be well, probability of well given medication, M for medication. So half the volunteers received the medication, so 0.05 is the denominator. And the probability of a volunteer receiving the medication and getting well was 45%. So well and medication was 0.45. 0.45 divided by 0.50 is 0.9. Or of course you could say 90%.